Yeah, my name is Juho Jaakkola. I'm part of the Nokia data center sales team in Europe. I'm presenting the technical side of our sales. Still working on the sales, but after roughly 20 years in different data center positions, I consider myself a little bit techie. Nokia, you remember the phones, right? So what are we doing with the data centers? So hopefully after this presentation, it will be a little bit more clear to you. I'm going to talk a little bit about the layered architecture. That's the way we see the future of data centers will be deployed. It's not about how you cool it, even though that's very important. It's not how you build it. Is it a brick or mortar, or are you using containers? It's about how you deploy your application across the different deployment models. Okay? I'm going to show a few products for those. Talk about a little bit more what we have just launched and contributing to open compute really soon as an incubation. And spend a little bit time also how we see the next technological trends, what we will see in data centers. A little bit of kind of roadmap item. Yeah, not the mobile phone. Actually, there is a Nokia branded phones, but they have nothing to do with the Nokia, except the patents that we own. So these are the Nokia corporations, business groups that we have. Mobile networks, that's the group that I'm presenting. As the name says, we build mobile networks. 2G, 4G, 3G, and really soon 5G networks. Everything related to mobile networks is on that part. We also have fixed networks, how you get your ADSL connectivity, to copper modem type of thing, but also we provide our knowledge to companies like Google and Facebook to build marine optical cables. So everything from home to intercontinental fiber channel connectivity, that's on those business groups, as well as Ethernet switching and routing, of course. Nokia software responsible for, surprisingly, software, not just the telco-specific things, OSS, BSS, charging, what have you, but also OpenStack. We are heavily investing development of OpenStack, and we do have actually 2 different flavors of OpenStack. Global services, well, those are the guys who will integrate the systems from different business lines, but also from different vendors. Nokia Technologies is handling the patents. Nokia have a huge patent portfolio. And of course, we have Nokia Bell Labs, which is an organization that all they do is R&D. So those are the really smart guys. Really, really smart guys. And girls, of course. About the R&D, 37,000. Every third people in Nokia is doing R&D. And all our money goes in R&D. So that's a huge part. And what comes out of that R&D is a lot of patents. Now 9. Yesterday it was 8 Nobel Prizes, now we have 9. 1 Oscar. All these are, by the way, in our headquarters, Espoo, on Executive Experience Center. That's kind of a demo environment. All these prizes are on the wall there. So if the Tesla took off the patents, that's understandable. It's not like you have, Nobel Prizes or Oscars or Emmys. So we like to show these off. All right, let's move to real stuff. These are the 6 megatrends that Nokia sees, and it's not just affecting how the Nokia is doing business, it's affecting how people are communicating, how everyday life and everything. So these are the huge trends that we are trusting to become reality very soon. And actually, if we look the networked storage, cloud computing, that's already here. IoT, huge thing. We have just deployed a fraction of the IoT platform that we will see in the future. We will see everything connected. And for Nokia, of course, you need to connect these devices or things somehow. We see potential how to connect those. Augmented reality, augmented intelligence, virtual reality. There are, of course, some deployments already. We've seen our customer deploy what we call video orchestration, local video orchestration for sporting venues. When you are watching a soccer game, football game, you have additional stream of video locally for your mobile where you can choose different camera angles. There are just few of those in the world. One is in China and one is in Saudi Arabia, I guess. That's a huge thing. And it requires a certain type of data center behind to make it happen. Human interaction. Actually, I do have video about our AI data center assistant called Mika. How we use machines and how we use devices will definitely change. Augmented reality is the key technology to do that. You have additional information through your mobile device, feed it to you from the cloud, which of course helps you to operate the machines. Blockchain, I guess that's the hottest thing there now. I guess it's in the very top of the hype curve. It will change security, trust, maybe financial sector also. But anyways, these are affecting our lives. One thing common for all these is that they do require layered architecture. And by the layered architecture, I mean something like this. You need huge centralized cloud to run your, what we call signaling driven application. Let's have an enterprise or enterprise kind of example. These are the applications that require a huge amount of resources. Let that resources be the CPUs or storage. Anyways, you need a huge amount of those. So those applications will be placed on centralized. Part of that will be on a public cloud, of course. So we see that centralized architecture is pretty much aligned with the public. But then, when we move to the closure of the end user, we have totally different kind of requirements. And the main driver for those deployments become the latency. There is, and I will have examples later on, there are multiple use cases, applications, that cannot be done from the centralized data center. It just can't be done because of latency. Between those, we are talking about the regional and aggregated edge. These are a little bit of telco terms, but those are the data centers that consolidate computer storage closer to the end user, but still not on the end user premises. How we see this deployed is that we take a look at application, the use case, define the requirements, and then place it accordingly on top of this architecture map. Let's have another view of this same architecture. On centralize, we see that per enterprise there's a two to three of those for redundancy. We really can build that large data center to hold everything, but you need geological redundancy, so you need to build few sites, maybe 3 in extreme cases. These are very, very large, thousands of servers, starting from thousands of servers. Regional, we are talking about hundreds of servers, and up to the smallest footprint, we call far edge, up to 5 servers. Okay. So no OCP there, at least yet. Let's see how our proposal goes through the incubation, but we will see. We are using Open Compute in our Espoo R&D site, roughly 4,000 nodes. That's purely R&D environment running OpenStack cloud. It's a quite big private cloud, I would say. But also we use rack mounts where the Open Compute rack cannot be physically fit. As it said, it's quite heavy. And also in those deployments where we only need 15 servers, it really doesn't make any sense to push the Open Compute rack, even though it's really cool. So different deployment models requires different kind of hardware. Quick view to our portfolio for the data centers. On the top, there is a telco-related thing. We of course provide VNFs, the virtualized network functions, OSS, BSS software. We have OpenStack distro called CloudBand. That is enterprise-capable OpenStack with telco flavor. And the telco flavor means that we can use SR, IOV, and DPDK. So for telco workloads, let me explain that one. Telco workloads are basically taking a packet from the network, do something to the packet, and then push it packet out as fast as you can. So for those applications, we need to do hardware acceleration. The Xeon CPU is not enough. Well, Xeon CPU is enough for the generic workload, but for the package handling, we need to rely on something else. So we will bypass the kernel and access the hardware directly to get those millions of packets through the systems. That's the telco flavor. We also have a real-time extensions on the OpenStack. We need to know how long does it take that packet to go through the system, and for that we need real-time kernel. Real-time kernel doesn't boost up your system to the real-time computing that everything happens in just like that, but it gives us to control how long does it take to go the packets go through. We have Open Compute as a hardware in our portfolio, servers and storage. We have rack mounts for customers that are deploying a smaller site. And then we have what we call Open Edge. I will give you an introduction to Open Edge a little bit later. Nuage Networks was part of the Alcatel-Lucent merge, and Nuage is building Ethernet switches, IP routers, but also SDN, the software-defined networking. You cannot build cloud without SDN. It's just not possible. You need to automate every single step on your cloud, otherwise it's not a cloud. and SDN is the final key for that. We've been virtualizing servers now almost 20 years. My first contact to VMware was '99 with VMware Workstation on my Linux box. So it's roughly 20 years now, and IBM did that before that, before VMware. So finally we are virtualizing the network, and SDN is that one. So our solution is called Nuance. NetGuard, that's well, a little bit telco specific. It's our security suite to do the endpoint security and intrusion detection and that sort of things. One big thing, and we are seeing a huge growth here, is containers. Well, when you say container, depending your audience, it's a Docker or is it a shipping container. In this context, it's a shipping container. As we move to the edge, we need to bring the compute as close as the end users at the creation of the data point. It's not possible to have data center facilities with the necessary cooling and power requirements on every single environment. That's why we are building container-based data centers. From one single rack container, that's on the left side, to containers that can host up to 8 racks. It includes everything. It's a cooling, it has the diesel generators available, UPS and so forth. And these are kind of turnkey solutions. So we build it on our factory in Espoo or in our partner factory. Everything is cabled, ready. You just need to plug in the power and your data center is ready to run. Especially in those cases that the environment cannot support data center, or it's not possible to build new facility, or it's not financially wise to do that, then we use these. Moving to the 5G, any day now. 5G networks, because of latency requirements, need data centers that compute as close as the user possible. That's why we are building these. And of course we have the services, so everything is covered on that side. Airframe is the brand name of Nokia data center products. We have open compute, platform, rack, servers, and storage unit, that's a JBOD. And we have the rack mounts, and then we have open edge. One thing about the open compute in generally, and I guess it's the only thing that is not yet mentioned, is that it really drives software-defined data center. Because of the vanity-free design, it's everything that is not absolutely necessary is left off. It's built actually other way around that your average servers are. When designing those servers, for example, only the components that are really necessary are picked up, not the way your average industry standard server is built, that you have all the possible components put in the box and then sell it to the customer, even though that they don't need RAID controller, even though that they don't need BMC, proprietary BMC, all the features that you have. BMC is the baseboard management controller, ILOs, DRACs, what have you. So it really drives the software-defined data center. That's why there is no specific storage unit. There is just a JBOD. JBOD is connected with the SAS serial SCSI to the server. There might be, in some cases, there might be SAS switch, so you can do the zoning if you want to share the JBOD with multiple nodes, or within single node you want to have SSDs and spindles, but that's it. Very simple. Those are 2 CPU servers. which means that you can compare the amount of memory and amount of CPU cores that you have to 1U, 2U rack mounts. Well, rack mounts are rack mounts. That's boring stuff. Then there's this one. This is the open edge. That's specifically designed within OCP principles, the openness, the efficiency, scalability, and so forth, to fit in very small deployments. That's a five servers in 3U box. It might look like a blades, but it's not definitely blades. On blades, you share more than just the physical environment. You share the networking, you share maybe the management in some level. These are independent, low-cost, one CPU servers. But I will give you a little bit more details. But whenever you see text airframe, it refers Nokia servers and data center products. If we compare these, it's obvious why we are talking about that on centralized data center we are using open compute based systems, and when we move to the edge we are using something different. Actually, in that picture there is a 1U rack mount, and top of that rack mount there is a open compute OCP server, Nokia OCP server, and Nokia Open Edge server. Same CPU, Skylakes. There is no much that I can enhance your OCP experience, how good the OCP is. But there is on top there is a PUE from different data centers. Nokia is currently 1.08 in our data center. And how we do that, it's not just the open compute. But we are actually doing this at Tampere, 3,000, 4,000, something like that servers. We are taking the cold water from the lake, running through the heat exchangers, and run that through the racks. We are not putting the water in the servers. That's a generally bad idea. We are cooling the rack itself. That's the reason for that is that you can have any component in there. It's not just one specific vendor component. And when we heat the water through the IT workload, so to speak, we are pumping that back to the city of the Tampere, and they are using that to warm up the swimming pool. And it's closed loop, exactly the same way that there was in the Lenovo presentation. There was this closed loop. So one loop takes the cold water from the lake, another loop is our data center, and third loop is the one that is heating up the swimming pool. And we've been doing that last 4 years or something. So already doing, and available also for our customers if they want to see the data center. So that's one thing. It's not just the OCP hardware. You need to design all the data centers around that. We are a platinum member, Open Compute, and we have co-lead Greg White on a telco project. Of course, we are interested very much in the telco side of the Open Compute, so we have co-lead there. And OCP inspired for our Open Edge. So why Nokia is so interested about the Open Compute and data centers? This is why. And actually, these numbers are, by the way, there is no Facebook, Microsoft, or Rackspace in these numbers. So these are the actual numbers. The big boys are not in this. So if we look, here are the numbers, and it really makes sense. For telco operators in the world, the Open Compute is #1 option. With the 5G, with the cloudification of the network functions, everything is now x86. Everything, almost everything is virtualized. So telcos with the huge volume that they have and the upfront investments that they have to make, you cannot start building 5G network with just one antenna and a few servers to run the packet core. You need to build the whole network at once. So the price of the hardware is very important, but also how you can run it, how efficiently you can run it. Telcos in open compute will double the amount, and for the numbers, they will be the number one driver in open compute. This is why we are on the market. Okay. OCP, maybe OCP, then we go to the rack mounts, and then to the edge. A little bit about that edge. There are some requirements for the edge in general. You need to provide certain performance, but you have constraints when it comes to the space itself, but also how to cool it and how to power it. That's why we are looking for acceleration. FPGA, GPUs, and maybe some ASICs that will do the job. For the edge, you need to scale the deployment, multiple sites to hundreds of sites. To run that, China have this image recognition system for security. There is a multiple sites to do that. And we have discussed with the China Mobile how many edge sites they will have. As 2020, China will launch the 5G network countrywide, or almost countrywide. So there's tens of thousands, hundreds of thousands of those sites to make that network happen. So you need to scale it. But you need to scale also the management. Then there's some security issues. The data cannot leave from the site. That's one thing. But there can be some government compliance things also. And our customers would like to see it open, especially the open APIs. When you build your automation based on the proprietary APIs, that's a generally bad idea. It's a truly vendor lock in there. We believe that every API that your hardware expose should be open. Why the latency? Why we need to go so close to the customer? Few examples about the latencies and the important, or there should be a laser pointer here. Is it this one? Yes. So vestibulo, there it is, reflex. Do you know what it is? That's the reflex in human body that made humans. Well, if the evolution is your thing, I mean, that's the part that made us such a successful. So it's a reflex that balances your eyes when your head moves. And that's very important for all virtual reality use cases. Just to give you about the latency. If the latency from network plus the application is more than that, you will feel motion sickness during the most of the people will. So if we want to provide 4K 360 virtual reality, we need to go very close to the customer or end user. Of course, there is other use cases that requires that low latency. The thing is that though the speed of light is a constant, it's a law, we cannot do anything about that. Oh well, we can slow it down, but not speed it up. That's why we need to go closer. That's basically. Some cases, of course, you want to save the bandwidth, so you don't want to move all the the data from the cloud to the edge and back. But most of the driving use cases is the latency. Yeah. So airframe, OpenEdge, 3U, 5 servers, 1 socket servers. Why 1 socket? Because we don't need more. When it comes to network, package handling EPC, the function that makes your mobile phone browsable, cannot consume more CPU, just 1. So that's why we have 1. Another reason is that we don't have to take care of NUMA crossing. All the memory and all the PCI devices are local for that. We are proposing that chassis to Open Compute as a new project. And I guess, I haven't been in Amsterdam this week, but I guess that our team did presentation there and proposed, yeah. Okay, good. As we are not fixed on that form factor, we can have different form factor. Actually, the GPU use case is one that we might need to beef it up. Maybe have 2 of those as a one node. Based on total open Redfish management, use whatever tools you want. I would use Ansible along with our data center manager. Pure Intel chipset, Intel network devices, NICs and Mellanox NICs as well. Even though that the 5G radio is why we did design that, and actually it's driven by one of our customers that wanted this kind of hardware and there wasn't any on the market. IoT could be a very interesting use case. IoT gateway. That image recognition, you could run these on the airport or whatever is the facility that you're monitoring and do the initial image recognition processing on the edge and then just move that necessary data to the data lake. Basically any x86 workload that doesn't require more than 22 cores can be run that. CDNs, content delivery networks and so forth. Because of the only 1 CPU, we need to rely acceleration. We have our own ASIC. Actually, we have multiple. The Reef Shark is from very telco specific. We have a routing engine for the IP routing, but we are heavily investigating and doing R&D in FPGA cards and as well as GPU. With 1 single CPU, Xeon on the box doing the generic workload, then you really can benefit for the programmability of the FPGAs and the huge floating point performance that you can get out of the GPUs. So that's an important thing. Management. I would say that hardware is a bit boring. This is a bold statement for the hardware salesman, but it is. I mean, it's Intel, good data, AMD, and that's it. The management, the automation, that's where the things get interesting. If you can streamline your operational side, automate tasks, that's where you get real benefits. That's how you reduce your TCO. We have our own product for that. It's based on 24 different open source projects. We use Grafana, we use FluxDB, we are using containers, or we are running it on containers. We have a MySQL database there, we are using Nginx for the front and so forth. So it's a collection of the openness put together. It can automate your firmware updates, BIOS configuration, operating system deployments. So what we did in Europe, our guys built an Ansible play, and they remotely installed the racks roughly 30 minutes per rack on site. So only thing that was done on the site was connecting 2 power cables and 4 fibers to the network. It relies on Redfish. If you don't want to use this one for our hardware, feel free to use anything you want. But if you want to use already built features like performance monitoring within the data center manager, we also expose the RESTful API, the northbound API, to the customers so they can build their own automation on top of this. So this is the part that takes care of configuration and firmware updates and operating system installation. This is what's next. Actually, we do have this one, demo on Espoo. So this is not just a... Let's see. I will switch from the presentation mode to, if I can show you the video. Should there be a... Oh yes. Oh, sorry. I'm better with a Linux than I'm with a... Oh, so much better. Let's try again. No, still on the presentation mode. Okay. Still. Okay. I'm not going to spend any time to trying to debug the...
Are you trying to come out into the browser and just run it on YouTube?
Yeah. Oh. Juho versus PowerPoint. First round, 1-0. Let's hope that. Okay. Well, yeah, don't know why is that, but let's not worry on that. I will browse it from the YouTube. You can find it from the YouTube with the airframe Mika concept. But by googling that, it's a augmented reality assistant. We're using the HoloLenses to guide you through the data center. So it will add some information about servers when you look at the servers, and actually it's guiding you to installing new server and how to remove all the thumb screws, or well, the one thumb screw that you have, and how to physically install the server. So what's next? This is what we are investigating. These are the topics that Nokia R&D is looking for. Well, we have already that edge thing. We have 45 hot swappable drives in our Open Compute JPod. NVMe over fabrics. This is very interesting, and some might say it's a future of storage in physical, not the software layer. This means that we could access basically accessing PCI devices, the NVMe memory, over the fabric. In this case, it's Ethernet. As we are working closely with the Facebook, the Ethernet is our option, but fiber channel might be also an option for that. That's something that we are doing. FPGA acceleration, but also iNICs. You might other vendors might call them smart NICs. That's the type of Ethernet network interface that can offload your virtual switch. You are not running your virtual switch in a user space. You are putting it to the NIC itself and run it on the NIC, reducing latency. Rear door cooler. Replace your normal rack door with a cooler. Not all the data centers are capable to handling the 25K, at least 25 kilowatts that your OCP rack is generating heat. By bringing the cooling closer to the rack, might help in that kind of situations. In physical data center, I would say that high voltage 400 VDC is the biggest thing. Running 500 VDC directly to the rack will drop multiple transformation and unnecessary step off and really helps with the efficiency when it comes to the power and distribution. And we are shrinking the open rack. Reason for that is the doors, especially the lifts. It's not just one time, it's not 2 times, it's 10 times at least that we have shipped the rack. We have said that open compute rack is a 50 units, and when our guys are on the site, they found out that the rack doesn't fit. And if you have 1.5 ton rack, you don't tilt it. So we have to shrink that for the special telco cases or customers. Not necessary problem with your hyperscale data center, but for the telco data centers, we have to chop off few rack units to make it possible. Single socket servers, not just the edge. It might be that because of the mainly AMD EPIC with the huge amount of cores, it might be that the single socket servers make kind of comeback because of the price point, but also the TDP, so the power envelope that we have on that. Okay. I hope this gave you a view to what Nokia is doing these days, not mobile phones anymore. And if I will be here till my ferry leaves, so evening. So if you have any questions, please pull my sleeve. And of course we have now perhaps time.
We have some questions now. Applause to Juho first. Yeah. So for what did Nokia get an Emmy, a Grammys and Oscar?
Oscar is from Sounds. I don't remember which movie, but that's the developing. Well, it's a Bell Labs. Bell Labs developing some system for the sound as well as the Grammys. The latest Nobel Prize is laser tweezers.
Okay.
So you can use laser beams to move around viruses and bacteria and even subatomic particles or something like that. Very useful every day.
Yeah.
Yeah. But there's a LCD, transistor, microwaves, so it's a big list.